Hello everyone, welcome to Lectrick YouTube channel. In the last video we discussed resistors. So today we will continue the remaining portions. Last video we have covered what is resistor and its types and its characteristics and when resistors are connected in parallel and series how it will behave and the various effects and how the temperature will affect the resistance value and the voltage coefficient of resistance. And today we are continuing this session. Power rating and derating curves. Resistor must be operated within specified temperature. There are limits like maximum limit and minimum limit, the temperature. So when it exceeds, then the resistance will be damaged or won't work properly as it meant to be. So temperature limit is defined in terms of maximum power called the power rating. The power rating of a resistor is the maximum power in watts which the resistor can dissipate. Maximum power rating is a function of resistor material, maximum voltage rating, resistor dimensions, and maximum allowable hotspot temperature. Hotspot temperature means it is the temperature of the hottest part on the resistor when dissipating full rated power at rated ambient temperature. So by this graph, you will get to know. So for the values of resistance below critical value, which means this x-axis is the resistance and y-axis is voltage or power, is critical value of resistance. This is critical value of resistance at which when at this point you will see rated voltage and rated power you will get with the critical value of resistance. Below critical value of resistance, then you see in the first sentence it will defines that below critical value the maximum voltage never reached. So maximum voltage is rated voltage, so it below critical voltage it won't reach it. At critical point only it will reach, and the above critical value the power dissipated is lower than the rated power, so the rated power rating will be less for this thing. So at critical value point only you will achieve rated power and rated voltage. Through this graph you will easily understand. Then voltage rating of resistors. So how we will calculate voltage rating? This is the maximum voltage that may be applied to the resistor is called the voltage rating, and it is related to the power rating by V is equal to P square root of P into R. That means P is the power in watts and R is the resistance in ohms and V is the voltage. For example, in some cases you might get voltage also, and you will get the resistance value also. Then you need to, by that time, by using this formula itself, you need to calculate the power rating. Next, move on to the color coding of resistor. This is the main part of the resistor, because whenever you are using in electronic circuit you will find out the resistor with different colors. This is, for example, this is a resistor, this is a resistance. There is no polarity in the resistor. In case of capacitor, polarity will be there. So here there is no polarity, any end you can connect, you will get a different colors. So it will indicates the rating of the resistor. What is the value of the resistor? Resistance value. For example, 10 ohm resistor, there will be a different color. In the next slide, we will see the chart. So based on that, how we need to calculate, identify which resistor having which value and all. So composition and film resistor it is used, and color code is essentially consists of 4 bands of different color. One is 1, 2, 3 and 4. So these 4 bands it will consider. This 1 and 2 are the digits directly, like first band is the most significant digit, and second is the second significant figure, and the third band is the multiplier. That means it will multiply into this 1 into 2 and into resistors you won't fourth band, because there will be a tolerance. We will go to the next slide. If the fourth band is not present, the resistor tolerance is a standard 20%. Now we will calculate. Okay, for example, I will say 100 ohm resistor का color value हमको चाहिए ना. So for that you need brown. So this is brown is indicating 1. So brown. Then first band will be brown. Okay, second band will be 0. That means black. second color will be black, then 100. So it's already 1 and 0 got na. Band will be multiplier. So if I multiply into 10, then you will get 100. So 10, 1 and 0 is 10 into 10. That means brown. Again brown. Third band is brown. This is also 10. 10 into 10, 100. So this is 100 ohm. So in order to get 100 ohm resistor, you need color code of brown, black and brown. So this fourth band will be tolerance. It will be vary like gold, silver, and if there is no band, then you need to consider 20%. If that resistor doesn't have any fourth band value, you need to consider 20% tolerance. That means if it is 100 ohm, so then this is 20% means plus or minus 20 means like it may be 80 ohm or 120 ohm like that. So this is plus or minus 20. So for that also, like in our academics, we have learned BB Roy, Great Britain, very good wife, in order to remember the what's that each each names. So by using that formula, I will write that BB Roy, Great Britain, very good wife. So for example, we will look at one more example. So I need 33 33 kilo ohm resistor value. So believe it, 33 range 3. First is 3, then second also 3 we need. So second band also 3 ka orange. This is also orange. Then kilo ohm. K means 1000. What K means 1000 means that is also orange. So this is also orange. For in order to get a 33 ohm resistor, you need orange, orange, orange. First three bands should be orange, orange, orange. Then the last band, anyone gold, silver, or no band. So this is how we can calculate by using this color chart. You need to remember the uh, all the names in a proper order. So now we will discuss about resistor types. What and all are classified mainly as fixed resistor, variable resistor, and special purpose resistor. So what are fixed resistor? Value cannot be varied after manufacture. Okay, fixed resistors are classified into composition resistors, wire wound resistors, and metal film resistors. Okay, in the wire wound resistors, these are made up of like a wire of nickel chromium alloy and a ceramic tube covering with a vitreous coating. So spiral winding resistor has inductive and capacitive characteristics that make it unsuitable for operation above 50 kilohertz. High frequency effect in the last video we have discussed already. So the frequency limit can be raised by non-inductive winding so that the magnetic fields produced by the two parts of the winding cancel. So in the composition, composed of carbon particles mixed with a binder. This mixture is molded into a cylindrical shape and hardened by a baking. Leads are attached axially to each end and assembly is encapsulated in a protective encapsulation coating. Color bands on the outer surface we already calculated also. So resistance value and its tolerance. So fourth band will be tolerance, and composition resistors are economical and exhibit low noise levels for the resistance above 1 meter. This is mega ohm. The metal film resistor. Power resistors are used for power supplies, control circuits, and voltage dividers where operation stability of 5% is acceptable. Power resistors are available in wire wound and film constructions. Resistors where we will see. So first one is potentiometer. This is a resistor coil. Okay, this is point A, this is point B. Now we are introducing one more point as C. This pointer link to here, then it will include until here the resistance. So resistance increases. This potentiometer is a special form of variable resistor with three terminals. As I told, this is a three terminal resistor. Two terminals are connected to the opposite sides of the resistive elements, and the third connects to this sliding contact. As I told, pointer sliding contact that can be adjusted as a voltage divider. Potentiometers are usually circular in form with a movable contact attached to the shaft that rotates. So as I told, you can rotate this. See that sliding contact. By sliding this contact, you will get a variable resistance value. Potentiometers are manufactured as carbon composition, metallic film, and wire wound resistors available in single turn or multi-turn units. The movable contact does not go all the way towards the end of the resistive element. As the sentence indicates that there will be a small portion of the resistant manufacturer will always leave for the safer side. Otherwise, a small resistance called hop off resistance. It is called hop off resistance to prevent accidental burning of the resistive element. Why? So for example, if the point move directly to this up to B point, then there is no resistance in the circuit at all. It will be dead short circuit like that. So that's why they are including hop off resistance. So this is also important. Next is rheostat. So in the rheostat in your labs you might have used. So rheostat is a current setting device in which one terminal is connected to the resistive element and the second terminal is connected to the movable contact to place a selected section of the resistive element into the circuit. Typically rheostats are wire wound resistors used at speed controls for motors and ovens and heater controls, and in applications where adjustment on the voltage and current levels are required. So this is my rheostat. Okay, so this is winding. Okay, there will be one more sliding contact will be there here. Then you're connecting one wire from here, and this wire will be connected from here. So you see, when the sliding contact is moving, then when the, for example, current is flowing from here means you will get you will get more resistance value. Then what if this movable point come to here? Then then there will be a very less resistance applied getting here. IC resistors. Integrated circuit resistors are classified into two categories. One is semiconductor resistors and deposited film resistor. Semiconductor resistors use the bulk resistivity of doped semiconductor regions to obtain the desired resistance value. So now we will go to the varistors. Varistors are nothing but like voltage dependent resistors that show a high degree of non-linearity between their resistance value and the applied voltage. They are composite of non-homogeneous materials that provides a rectifying action. Varistors are used for protection of electronic circuits, semiconductor components, collectors of motors, and relay contacts against overvoltage. To the thermistors. Thermistors are resistors that change their resistance exponentially with changes in temperature. So as I told, like there is a positive temperature coefficient of resistance, negative temperature coefficient of resistance. That means how the temperature, the rise in the temperature or change in the temperature will affect the performance of the resistance. We already in the last video we have discussed. So in continuation of that thing, so if the resistance decreases with increase in temperature, then it is called negative temperature coefficient resistor. So thank you for watching. So please like this video and please write a comment below on this video. Okay, thank you.